Hey, so let's look at some questions from the Module 1 Lesson 7 problem set. Lesson 7 is all about identifying the constant of proportionality in a given proportional relationship, and then using that information to make conclusions or predictions about other unknown values that you're given, right? Like using the relationship to find stuff that's still unknown. So let's take a look at number 1 here. It says bananas are 59 cents per pound. So what is the constant of proportionality, or K? Well, just by reading the question, you might be able to just tell that the constant of proportionality is 0.59 or 59 cents per pound. But it might be clearer to see if you just make a little table, and you could call this your X values over here and your Y values over here, and maybe this is 1 pound for 59 cents or $0.59, and this would be 2 pounds. Well, how do you figure out how much 2 pounds costs? Well, you need to take 2 and multiply it by the price, which would be 2 times 0.59. So 2 times 0.59, and I can tell that's $1.18. Because what I'm doing is I'm doing the 2 times the 50 cents gets me $1, and then 2 times the 9 cents gets me 18 cents. So that'd be $1.18. And then if I did 3 pounds, I would still need to multiply by 0.59 to figure out how much that is. And so I'm thinking, well, 3 times 50 cents is $1.50. 3 times 9 cents is 27 cents. So when I add those together, I get $1.77. And hopefully, when you look at the values in this table, you see that, oh, well, I'm getting each one of these Y values by doing X times the K. K equals 59 cents. And that's exactly the definition of a proportional relationship, a relationship where you can take the X values, multiply them by that same number that we call K, and get the Y values. So in this case, the answer to 1A is that the K is the 59 cents or 0.59. And then if we want to know how much will 25 pounds of bananas cost, well, we're essentially just continuing this table, but we don't have to do 4 through 24. We just want to know what is the relationship here. If X is 25 or 25 pounds, and we multiply that by 59 cents per pound, how much is that going to cost total? And it should be, a little bit more than $12 or $13, because this is 50 cents per pound, which is half of $1. So half of this is $12.50. But then you add that extra 9 cents per, I don't know, it's probably gonna be 14 or 15 bucks, somewhere in there. So let's use a calculator on this one. 25 times 0.59 equals $14.75. So there's our answer to question 1B. We should write a little conclusion though. We should write 25 pounds of bananas cost $14.75. All right, number 2 is kind of the same way. I'll show you how I would do that one. And then number 3 is also basically the same way, and I'm gonna leave that one to you. So there's one that you gotta do without my help. So number 2 says, the dry cleaning fee for 3 pairs of pants is $18. So let me use a different color marker just so it's easier to see what I'm doing here. I'll go with this one. So if we call this our X values, this our Y values, this will be, I guess this could be pairs of pants, like how many pants you're getting cleaned, and this would be the cost in dollars. And so the question tells us that for 3 pairs of pants, it's $18. So 3 is X, 18 is Y. And I'm looking for that number that when I multiply by 3, I get 18. Or in other words, another way to think about it is I could put a third column in this table, call it my Y divided by X column, and think, okay, so Y divided by X, that's 18 divided by 3, which is 6, which is also the exact same number we were looking to fill in this blank. 3 times 6 equals 18. So there's 2 different ways to get that number you're looking for. And I think we're supposed to assume that this is a proportional relationship because it's asking us what is the constant of proportionality. So it has to be this number here. It's going to be 6. K equals 6. And now we could just continue this on, like 4 pants times $6 each would equal $24, right? And this would still be a 6 here in this column. But they want to know how much will the dry cleaner charge for 11 pairs of pants. So let's do that. Let's do 11 pairs of pants times our K, which is 6. That's going to equal $66. All right, so we can write a little thing that says it would cost $66 to clean 11 pairs of pants. All right, so I'm going to leave number 3 for you to do. Number 4 is a little more complicated, so maybe I'll sort of get you started on it, and then you can go from there. So it says, each school year, the 7th graders who study life science participate in a special field trip to the city zoo. In 2010, the school paid $1,260 for 84 students. So that's a ratio, a pair of numbers that I think go together. So I'm going to underline them in that sort of magenta color. And then I have in 2011, the school paid $1,050 for 70 students. So a little bit less money, but fewer students too. So it seems like these ratios might be equivalent, maybe, we'll see. And then in 2012, the school paid $1,395 for 93 students. So more money than in that first year, but also more students. So the first thing it wants us to do is figure out whether or not the price that they pay each year, so the dollars, is proportional to the number of students, the 84, the 70, and the 93. So we're going to check all these ratios to see if they're equivalent ratios, or in other words, whether it's a proportional relationship. So let's just make a table. It honestly doesn't really matter which ones you make your x values or your y values, but I think it makes more sense to make your x values the number of students and y values the price, because then you're going to wind up dividing bigger numbers by smaller numbers, and that tends to turn out nicer. We'll have easier numbers to deal with. If you divide the other way, you're going to get these harder to work with decimals. So what are the 3 ratios we have here? 84 students costs $1,260. I guess I should have wrote that in pink to match that. Oh well, I'm all green now. I'm just going to stick with green. And then 70 students costs $1,050, and 93 students costs $1,395. So we just set up a table of values. I'm a little bit off the screen here. Let me see if I can adjust this. So we set up a table of values here based on the information they gave us in the problem. And now we want to check whether or not these values are proportional. Well, we've practiced this a few times in class. We just make a y divided by x ratio column, and we're just going to divide y by x, y by x, y by x. And if these numbers come out the same, it's proportional. If the numbers come out different, if there's even one different, then this is not a proportional relationship. I'm pretty sure it does turn out proportional. I'm not going to do the math for you right now, but I'm judging by the fact that question D says, what would the school pay if 120 students entered the zoo? I think you could really only answer that question if this is a proportional relationship. That's kind of why we study them. That's kind of why they're good, because they give you this ability to predict about future information or to predict about unknown information. So I'm going to guess that you're going to divide these and you're going to get the same number 3 times, and that's going to be your K. And so whatever number that is, take that and multiply it by 120 to get the price for 120 students. For E though, you got to kind of work the other way. If they paid $1,425, so if you're trying to do question E, I'm going to write this over here for you to see in a different color, not green. If you're trying to do question E, well, hopefully you already got a K from over here. K equals something, I don't know what. But you can work backwards. If you take this number of students and multiply by your K to get the price, you can take the price, $1,425, divide by your K, whatever that K is that you got over here, and that's going to equal the number of students. I'm going to go off the page. Wait, let's see. All right, so I don't want to do this one for you completely, but I think that should kind of help you get going on it. All right.